Okay, guys, now let's take a look at a system of linear equations and inequalities. Remember that a system is two or more equations working together to come up with a solution. The solution is going to be the point of intersection. So remember, a point is an x and y coordinate. So anytime you're solving a system, you're going to have an x value and a y value. Now, to have one solution, the slopes of the two equations are going to be different, and that will make the two lines intersect at one point eventually. When there is no solution, this is when we have parallel lines. Parallel lines have the same slope, they change at the same rate, but they have different starting points, different y-intercepts. So we have parallel lines, and they will never intersect. When we have infinite solutions, we have lines that coincide with one another, meaning that every point lies along the point of the other line. They have the same slope and the same y-intercept. So we have one solution, no solution, and infinite solutions. Now there are three methods to solve a system. We can solve by graphing, where our equations have to be in slope-intercept form, y equals mx plus b. We can use substitution as one of the algebraic methods where one of the variables in one of the two equations is isolated. The second algebraic method of solving a system is elimination, and this is where we have to have a pair of variables that have to be opposite in sign, such as 3x plus 2y equals 6 and 3x minus 5y equals 12. We need a pair of opposite variables. So let's solve by graphing. Remember, they both must be in slope-intercept form, y equals mx plus b. Our second equation is not in this form, this is standard form. So let's go ahead and solve for y. We're going to subtract 2x from both sides. Now we are going to divide each term by 6. And we have y equals negative 2. 6 simplifies by a factor of 2. So we have our slope and our y-intercept. So let's graph these. I'm going to graph the first one, and we're going to start at 0, negative 3. Our slope is up 1 and right 2, up 1 and right 2. Our second equation, we're going to start at 0, 2, and we're going to go down 1 and right 3, down 1 and right. And we can see that our two lines intersected at this ordered pair 6, 0. So 6, 0 is the solution to this system. This means if we plug in 6 for x and 0 for y into both equations, we will get true statements. This is the only ordered pair that both equations share. Okay, now let's solve by substitution. And the first thing that we need to ask ourselves, do we have an isolated variable in either of the equations? It could be the x, it could be the y. And we see here in equation 2 that y equals negative 5x plus 13. So we're going to take what y equals and substitute it in for the y in the other equation. The reason we did that is now we have one type of variable, and we were able to find the value of this one variable, x. So we are going to distribute this understood negative 1. So we get positive 5x minus 13 equals negative 12. We're going to combine like terms, and we're going to isolate x. The x value, the x coordinate of this solution to this system is 1. So I'm going to write 1 comma, make sure we put it in the right spot, x comma y. Now we're going to take what x equals, and I'm going to substitute it into equation 2. you can substitute it into either equation. Multiply, combine, and we get 8. So this system intersects at 1, 8. So something like this, I'm just going to sketch it. This is in quadrant 1. Remember, our quadrants start with 1 in the positive, and you go counterclockwise. This is quadrant 2, quadrant 3, and quadrant 4. So this is our point of intersection. This is the solution, 1, 8, that will make equation 1 and equation true if we plug in 1 for x and 8 for y into both equations. Now let's do the method, or use the method of elimination. We need a pair of opposite variables. We have negative 12x, we have a 9y, we have a negative 6x, and a 10y. So I'm looking at these two and I'm like, well, we could easily make this become a positive 12x, a lot easier than making this 9y and this 10y have the same or opposite coefficients. So let's multiply equation 2. We want to change the sign to positive, and we want the 6 to be a 12. So we're going to multiply through by negative 2. So I'm going to distribute the negative 2 to each term of equation 2. I'm going to rewrite it under equation 1. So my new equation 2 is going to be 12x minus 20y equals negative 4. Now when we combine these two equations, the x's are eliminated, and we have negative 11y is equal to 11. And now we're solving for y. The y value is negative 1. So I'm going to go ahead and write that in the y spot. It's the second one, x comma y. And now we can plug in this negative 1 into y into our first equation, our second equation, or even our new second equation. I'm just going to go ahead and plug it into equation 2. So we have negative 6x plus 10, plug in negative 1 for y. I multiplied 2 times negative 1. Now we're isolating x. And the x coordinate is negative 2. So we have negative 2 comma negative 1. That is the solution. That is the point of intersection of these two equations. They will intersect in quadrant 3. This would be negative 2, negative 1. So somewhere in quadrant 3, these two lines would intersect. Now, here we have a point, negative 8, negative 10, and we are asked, is this the intersection of these two lines? So the way we're going to test this is we're just going to substitute negative 10 for the y's, negative 8 for the x. So let's look and evaluate equation 1. Half of negative 8 is negative 4. We get negative 10 is equal to negative 10. That is true. So I do know that negative 8, negative 10 is part of this line. Now let's see if it's part of equation 2. Negative times negative is positive. We get negative 10 is equal to negative 8. This is not true. So this point is not part of this line. So this is not the solution. Now let's write a system and solve it. Joe has 20 coins of quarters and dimes. The total amount he has is $3.95. How many of each coin does Joe have? So first of all, let's write how many he has, and he has quarters and dimes. So I'm going to use Q for quarters. So he has quarters plus he has dimes, and that totals 20. So this is how many coins. Now let's represent the total of how much he has. So the value of a quarter is 0.25 times how many quarters he has, plus a dime is 0.10 times D, and the value that he has altogether is 395. So we have equation 1, equation 2. Now remember, when we're working with decimals or fractions, we can always multiply our entire equation by a number to make our numbers look a little bit easier to work with. So I'm going to multiply by 100, and this is going to give me 25Q plus 10D equals 395. So this is my new equation of the amount. So now we have Q plus D equals 20 and our new equation here. So I am going to make my D here be negative 10. So I'm going to multiply through by negative 10. This gives me negative 10Q minus 10D. So we're using elimination, and this equals negative 200. Now we're going to combine. We get 15Q. Our D's eliminate. We're going to divide each side by 15 to see how many quarters that Joe has. So that's why I like to use appropriate variables for problems like this. So when I get to the bottom, I know exactly what the variable represented. And so when we divide this, we get 13 quarters. So if he had 20 in all, so he has 13 quarters plus so many dimes equals 20. So we're going to subtract 13 from 20. And of course, that's 7. Kelly has collected 20 seashells and will continue to collect 3 more each day that she is at the beach. Taylor collects 5 shells each day at the beach, and she begins with 12 shells. On which day will they have the same, and how many shells will each have? So I'm going to write an equation for Kelly. She has 20, and then she's going to collect 3 more each day. So her total shells is 3x plus 20. X is going to stand for days. Y is total shells. Taylor collects 5 each day, so her total shells is 5x, and she starts out with 12. We want to know at what day will they have the same amount. So we're going to use substitution. So I'm going to take 3x plus 20 and substitute it for this y. So we want to know at what day do these two folks have the same amount of shells. So we're just setting their expression equal to one another. That makes sense. So we have variables on both sides. And remember, I've told you, address the variables first, not the constants first. So I'm going to subtract the smaller variable term from both sides. And now we're solving for x, the number of days in which they will have the same amount. So x is days is on day 4. So on day 4, they will have the same amount of shells. Now we can substitute 4 into either of these equations. And y, total shells. So the total shells is going to be, whoops. Not sure what happened there. Sorry about that. And so y equals 32. So on day 4, they have the shells is 32 each. Okay, now let's do a system of inequalities, and this time instead of having a single point for the solution, we will have a region. So these have to be in slope-intercept form, and what we have to remember is if we multiply or divide by a negative, we have to flip around the inequality. So we're going to subtract out the 4x from both sides. We're going to bring down negative 3y is less than negative 4x plus 6. We are dividing by a negative 3. So I'm going to remember that we have to reverse the inequality because we divided by a negative. Negative divided by negative is positive. And let's go ahead and solve equation 2. divide by a positive 3, so I do not need to flip around the inequality. There's really a negative 1 in front of this x, so it's negative 1/3 x. And now let's graph this. So I'm going to start with the first one. We're going to start at 0, -2. We're going to go up 1, 2, 3, 4, and right 1, 2, 3. Okay, now we look back and this is just y is greater. It is not equal to, so we have an open line, so that is dashed, meaning none of those ordered pairs are part of my solution. And y is greater, so that means we're going to shade above. So all of these ordered pairs are solutions to that first inequality. They would make it a true statement if we plugged in the x and the y value into the equation. Okay, our second one, we're going to start at 3, 0, 3, and our slope is down 1 and right 1, 2, 3. And then it is included, we have the equal sign, so it is a closed line. And its y is greater, so we shade above this line. So you can see, if you can see, our solution where they overlap is this area right here. All this overlapping. Let's see, we may have a highlighter. So those are your solutions. Any of those ordered pairs would satisfy both of these equations.